Hello and welcome everyone to today's workshop on real-time fan sentiment analysis during an Oracle Red Bull race. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today we're excited to analyze insights from Twitter conversations and show you how to apply sentiment understanding for a more complete picture of the emotions of an Oracle Red Bull race. If you do not currently have an Oracle Cloud account, we've got a special promotion with extra credits that you can try out the services and follow along with the lab steps today. We'll go over the steps to get started in just a minute. We'll also be recording the session, so if you'd like to complete the lab later on at your own pace, we'll be sending the link to the recording via email to the same email that you registered with for the event shortly after the workshop concludes. If you have any questions during the workshop, we've created a channel in our developer public Slack group. You can access that at the QR code there or at bit.ly/odevrel_Slack. And once you're in, you'll land in the general channel. From there, you can search for Oracle AI ML Services to reach our dedicated space for Q&A. However, we will also be checking the Zoom chat and the Zoom Q&A as well. Today's workshop will be presented by Yanir Shahak, Senior Principal Software Engineer, and special thanks to Wes Pritchard, Senior Principal Product Manager, who will be helping answer questions. You can access the lab guide by following this link here. I've placed it in the Slack channel and in the chat, and I'll just put that in there again in just a moment. But before I turn it over to Yanir, we will begin with a short clip presented by Victor Martin on how to set up your cloud account.
Hi, I'm Victor Martin from Oracle Cloud. I'm going to walk you through the steps to sign up for an Oracle Cloud free tier. Please follow along and pause the video when you need it. Oracle Cloud free tier gives you a set of always free cloud services. These services will be available forever. 2 autonomous databases, 2 virtual machines, up to 4 ARM processors virtual machines. You will also have a load balancer, block, object, and archive storage, monitoring, and much more. As part of your Oracle Cloud free tier, you will also have a 30-day trial with free credits to use in other services from analytics to Kubernetes. Sounds good, isn't it? Are you signing up for an upcoming workshop with us? Please make sure that you use the same email you use for the registration, as we have activated a special offer and you won't need your credit card to sign up. In any case, Oracle Cloud is not going to charge you for your trial. You actually have to explicitly tell us so when you are happy with all the Oracle Cloud services after your trial. Let's dive in. You need to add your country, then your first and last name. You also have to provide your email. Oracle Cloud has to check you are a human by asking you to resolve an easy challenge. Finally, click Verify my email to move to the next step. If your email has been activated for the offer, you will see the special Oracle Offer pop-up window with the type of offer already selected. Then click Select Offer. All the initial information is already in. Now you have to provide a strong password. I use a generated one, but you can select any you like. Just make sure you are in compliance with the strong password pattern. Confirm the password by typing it again. Fill the company name if apply. The cloud account name is essential as it is a unique identifier for your account. Select a name you like that is not taken. The home region is the region where you are more likely to deploy resources. You can deploy to other regions by subscribing to them. However, your free trial only supports one region. Select a region geographically close to you if you are not sure. I'm selecting Frankfurt region. At the bottom, click Continue. Fill the address information with city, postcode, county, and your phone number. Click Continue. The final step is to accept the agreement and click Start my free trial. Oracle Cloud starts provisioning your account. This takes on average 1 minute or 2. Then you are going to be redirected to the Oracle Cloud web console. Can you see the message "Your account is currently being set up"? It means that some services will still be unavailable for a few more minutes. Just keep it in mind. When Oracle Cloud fully provisions your account, you will receive an email. I will show you that in a few seconds. Go to the menu to explore Oracle Cloud Services. Also, the search bar is a friendly tool as you can search for compute instances, Kubernetes engine, analytics services, cost tools, user management, autonomous databases, Apex instances, and much more. On the right side, you will see the region you selected when you sign up. The next icon is Cloud Shell, a small free Linux instance with several tools pre-installed and configured like OCI CLI and languages like Java, Node, Python, and more. You can close Cloud Shell now, confirm with exit. The next one is announcements for updates from Oracle Cloud. The following is the help icon, where you can find documentation links, chat with us, post questions in our forums, and finally create a support request and request a limit increase. The next icon is to change the language, and the final one is the profile icon, where you can see your user information, your tenancy, and the sign out button. After a while, the message saying that your account is being set up will disappear. After a few minutes, you will also receive a getting started email and another one when your trial account is fully provisioned. Use the button in the email to sign in whenever you want in the future. You are all set up to enjoy your new Oracle Cloud account. Happy hacking!
All right, and with that, I will hand it over to Yanir.
Hello, everyone. Thank you so much for being with us today. Thank you, Tara, for this great intro. And we have Wes with us today. Wes is my colleague. Wes is going to be helping me with questions in the chat. So please feel free to, hey, Wes, please feel free to ask your questions in the chat. And please, Tara and Wes, if there's anything you think I should stop and address, please let me know. Also, if you could keep me honest on time so I don't get away with that with this webinar, that'd be great. So let's start with a quick presentation here. So just a few words about OCI AI Services. As you can see, our services are up here on the top, and they are built on a massive infrastructure of data and GPUs and data science, the data science platform sitting down here. And above all that are our AI services. So from the left, we have our OCI Digital Assistant, which is our conversational AI tool, a great way to automate services both in your organization and consumer facing. We have OCI Speech. This is one of our AI services. You give it audio, and it can transcribe the audio. It does a very accurate transcription with timestamps. It also punctuates the transcription. Next, we have OCI Language. We're going to touch and go deep on this service today. Essentially, you give it text. It gives you insights from unstructured texts. OCI Vision is next. We are going to also touch this service today. You give it images, and it can tell you, give you insights about those images, tell you what's in the image, scan text from it, and so forth. Document Understanding, as its name suggests, can give you insights from your documents. It can go and scan a document, give you the text, obviously, but also give you tables in a way that your application can consume and then create additional scenarios with. And finally, we have anomaly detection and forecasting. Those two services are working on time series data, and obviously can detect anomalies and try and give you a forecast of what's going to happen next. So a little bit about the services we are going to be using today. First, language. Some of the features for this service. Sentiment analysis, as we're going to use today. Translation from one language to the next. Custom model, that is when you have specific text, specific nomenclature in your body of text that you want the service to be able to detect and extract. You can teach the service to do that. You don't have to write a single line of code to do it. Next, we have language detection. Obviously, tells you which language the service, the text is in, and you can already kind of think and figure out that you can kind of mix and match some of these features. If you know that a certain text that you had received is not in a language you can read, you can use translation to then translate it to your language, and vice versa. Key phrase extraction, that's when we start going deep into the text and find the pivotal expressions within the text. Text classification, that's a general kind of overview of the text, what the text is really about. Is it talking about finance? Is it a medical text? And so forth. Named entity recognition, again, going deep into the text and pulling out names, dates, organization names, products, and so on and so forth. On the vision side, obviously object detection, you give us an image, we can tell you there is a tree, there is a car, there's a person, and so forth. Text recognition, we can do OCR, extract text written in the image and give it to you in a structured format. It can even detect some types of handwritten text. Custom models, again, if you want to detect something within images that our generic models cannot handle, you can do that with custom models. Again, no need to write a single line of code. And image classification, much like text classification, tries to look at the entire scene and tell you what's in it. So a little bit about the relationship between Oracle, between Red Bull Racing and Oracle. As you can see from this quote from their CEO, no other company came close. It's a very good and tight relationship. There are many things that Oracle is doing with Red Bull Racing, and we're going to focus on the last one, on the fan experience. Today, we're going to put on the hat of a social media manager or brand manager, and we are going to try and figure out what is the sentiment around the web about our brand, right? And this is very transferable to any brand. If you're in a position where you need to kind of get a sense of what people are saying about you. And now this lab speaks specifically about Twitter, but this is completely transferable to any other social media. It doesn't even have to be an external API. It can be one of your internal sources, either polls or reviews that employees send internally. But obviously, any other source of information where you collect reviews or feedback, you can use with this method as well. So we're going to put on the hat of a brand manager or someone that scans the web for sentiment, and we're going to build a solution around that. So a little bit about the solution that we're going to build, and I'm going to jump straight into the lab in just a sec. So in our tenancy, we're going to create a virtual machine or a compute instance. And in it, we're going to deploy some sample code that we have bundled with this live lab. This code is going to first start a web server, a simple web server, and listen to requests. And then we'll take those requests and proxy those requests and make additional requests to the language AI API and to the vision AI API, and obviously send the response back. On the client computer, we're going to have the client code. It's a very simple HTML and JavaScript bundle. We don't have a web server on the client for simplicity. That means that we have to do some hacking to make it work, but we're going to get into that in just a little bit. Overall, not a very complex solution, and I hope it will be very understandable. Okay, so let's jump straight into our lab. So this is our live lab. Let's do a quick run through of the various labs here. So first, introduction. I think that's clear. Get started, again, can help you with creating your Oracle account. I hope you were able to do this earlier. If not, again, don't worry. And I highly encourage you to create that account with the links that Tara sent you. You're going to get free credits on that account. In order to use AI services, you are going to need those credits because the AI services are not part of the always free line of services. So please make sure to take advantage of this benefit. Next, we have a lab talking about creating a Twitter developer account. Now, we're not going to do this today for several reasons. One, it is time consuming. Some accounts need to be approved and it takes a while, so we don't want to take time to do that. And lastly, consistency. We don't always get the right tweet flow. Sometimes the content is unsavory. So for the purpose of this demonstration, I've created a random tweet generator, and we're going to use that just for consistency. But the lab itself has all the code and all the explanations that you need to actually create your Twitter account and go from there. And as I mentioned earlier, it doesn't have to be Twitter, right? It can be Facebook or LinkedIn, Yelp, or anything else that you can connect to. Then we are going to create our compute instance. That's our VM, and configure it here. Next, we're going to set up the authentication. This is what will allow our VM to talk to the AI services. And then we're going to deploy the sample code and tweak it a little bit for our use. And then we are going to actually execute it and see it running in real time. Alrighty, so let's start with creating our compute instance. So first step, we're going to go into the main menu, click compute and instances right here. Now I've created a compartment. A compartment is just an organizational tool. We can create resources under it and we can manage it together. I've created this just to not mix it with other resources in this tenancy. I'm clicking the create instance here, and I'm going to give my VM or compute instance a name. I'm going to call it Centimeter server right here. Again, created in this compartment. For this demonstration, I'm going to change this availability domain, but you don't have to do that. This is just about some provisioning and capacity. Okay, so you can leave it as is. I'm going to leave most of the settings here as they are. Especially, I'm going to use Oracle Linux and this AMD shape. For networking, I'm going to create a new virtual cloud network, and I'm going to create a new public subnet. Again, those are going to be created in our compartment. Leave everything as is. I'm going to select to assign a public IPv4 address so we can connect to our instance in just a little bit. Speaking of connection, we're going to use SSH, a secure connection, to connect to our machine. So I'm going to click here on Save Private Key. As you can see, the key has been downloaded to my machine, and we're going to use it in just a little bit to connect to our machine. And I'm going to skip all the way to the end and click Create. This might take a minute or two to provision our instance. While we wait, let's peek ahead. And yes, as you can see, this has been provisioned. There we go. We have a public IP already set up. And let's look ahead. The lab obviously takes you through all of these details one by one. Now we are going to go ahead and configure network access. In order for our requests to make it to our VM, we need to enable the traffic. So in the list of instances, I'm going to click my newly provisioned instance. I'm going to go here in the primary VNIC section and click the subnet. This is going to take me to the subnet page, and in it, I'm going to security lists. You can think about this as a firewall, if you will. I click this, and this is the list of traffic, basically, that is allowed to get to my machine. As you can see, just a very small handful of protocols are allowed to make it to the machine, especially port 22, which is our SSH or a secure connection. And we're going to add one more. So I'm going to click add ingress rule. I'm going to say that everybody can send traffic to my machine. And I'm going to say they can send traffic to the machine on port 9000. This is going to be our HTTP port. I'm not choosing port 80 just for a little bit obscurity. Okay, we have that. Awesome. Let's move on. Now traffic will be able to flow. Again, we have all the information on how to do that. And now we are going to test our connection. Let's see if we did everything right. I'm going to open another tab just so we'll have this always handy. Let's move it here. Okay, let's go back to compute and instances. And I'm going to keep this handy because I need my IP right here. Okay, so how do we create a secure connection? We need a command line. We have instructions on how to do this in Windows. We're using this CMD or terminal for Mac. And I'm going to launch my, there we go. So we are going to go to our downloads folder. Let's see what we have here. We have our key. Perfect. One thing we need to do on Linux-based machines is change the security descriptor for the file. This is something I believe you do not have to do on a Windows machine. So moving on, we are going to issue our SSH command, and it's going to go SSH-I. Then we're going to specify our key file name. And then we're going to use the user OPC, which is the default user created for every VM. And then we are going to specify the IP for our VM right here. Okay, and hit enter, approve the first prompt. And as you can see, we have this prefix here, OPC at centimeter server. That means we are on our remote server. Perfect. So we have a good connection. We have a VM up and running with Oracle Linux, and we can move on. Perfect. All right. Now we are going to configure the compute instance. First thing we're going to do is, as we allow traffic on the virtual network in the cloud to flow into our instance, we also have a firewall on the machine itself. And we would like to allow traffic again on port 9000 to flow into our VM. So I'm going to copy these two commands and just paste them here. Once I tell the firewall to add port 9000 TCP, I need to issue a reload just to restart it and make sure that everything is working correctly. Next, we're going to install Node.js. Node.js will run our code. So I'm going to copy this command right here. This will take a couple of minutes to complete. So as you can see, it starts downloading all the various packages. So we are going to peek ahead and see what other things we can do. So this should complete, and then we need to create a folder called .oci. .oci is the common folder for authentication information that we use when we interact with an OCI tenancy. That's one of the ways to authenticate against a tenancy. And in that folder, we're going to have a configuration file that we are going to create in just a little bit. This configuration file will hold all of the authentication information we need to actually make those API calls to the AI services. So while this is downloading, I'm going to go back to my tenancy. And we can see this here in the setup OCI authentication. Right, there are a couple of ways to get to that screen. One through here, and that's what I'm going to use. I'm going to click user settings and scroll all the way down, and we have this API keys. Oh, I see that this has completed, so I'm going to answer yes. And now the installation is happening. Perfect. So as I mentioned, we are going to create let's go back one step, excuse me. And we are going to create our configuration folder. Okay, perfect. And as you can see, we have nothing in there yet. Okay. So going back to creating the API key right here. So on my user settings screen, I clicked API keys. I'm going to click add API key, and I'm going to click download the private key. Okay, so again, this is going to be downloaded to my downloads folder, as you can see right here. And as I click add, my tenancy is going to give me a bunch of information that we are going to use for the authentication. As you can see, the user OCID or the user ID, the fingerprint of my API key, the tenancy ID, the region we're in, and we're going to have to fill in that API key path in just a little bit. Right. So we're going to skip a little bit, and we are going to first copy that API key to our server, because this is where it is needed. We're going to use a command called SCP, much like the SSH command that we used, but I'm going to start a new window right here. So we can keep our remote window here, as you can see, with this prefix, the OPC at centimeter server, and I'm going to start a new one right here. So again, I'm going to my downloads folder. Now I'm going to have two files. This is the SSH key that we use to connect to the server, and this is our API key that we need to copy to our remote machine. So we're going to use the SCP command right here. And I'm going to need to replace some of these parameters. So first, much like SSH, we're going to supply the SSH key. Next, we are going to say which file we want to copy, and it's the Oracle Identity Cloud Service .pem file. And again, we're using OPC is the default user. Let's copy our IP. Paste it here. And lastly, we're going to specify into which folder we want to copy this file. As you remember, this is our .oci folder. So let's see what happens. Okay, perfect. Let's see if we have the file in the .oci folder. We do. Perfect. So next, we are going to create our config file. We do that with the following command. You can use whatever text editor you want. I'm using Nano here. And the information for this file comes from this blurb right here. I'm going to paste it as is. And if you recall, we need I'm going to save this file right here. And we need to specify our API key. This is the file name. I'm going to edit the file again. And right here, I'm going to replace this comment with the full path of the file. I'm going to say home folder, and init OCI and paste the file name. Now, just to make sure, I'm going to copy this. I'm going to save the file. I'm going to ls this. All right. I see we have the file specified correctly. Perfect. So now we have our config file. Let's just look at the config file in the .oci folder. We have all the information we need to make an API request. All right. So next, we are going to deploy the demo code to the compute instance. So the first step here is to use this link. And we have downloaded our code right here. I'm going to double click it just to extract it because we're going to take a look at the code in just a little bit. And we also need to copy this package of code to the server as well. The same package contains both the client and the server code. And we're going to use the same command. We're going to use SCP, or secure copy, to copy this file over. I need my local terminal, right? As you can see, this is my local terminal. Again, I'm going to paste my command, going back. I'm going to specify the SSH key, like always. I'm going to specify, yep, that's our code bundle. Again, I need the computer IP. I have it right here handy, and paste. And lastly, I'm going to say just dump it in my home folder. Let's see. All right. Perfect. So if I go one level up, I'm in my home folder. We have our zip file with the code. Perfect. So moving on, we are going to extract the code with the following command. And we're going to extract it into the centimeter demo folder. Perfect. If I go into the folder, here we go. We have all the code in here. Next step would be to configure the source code. This sample is written in TypeScript. So we are going to issue the npm install command just to install the various dependencies. This might take a few seconds. So let's peek ahead. Now, next, after we have all of our dependencies installed, we are going to take a look at our configuration file. It's a .env file. Its initial name is .env.example, and it has several parameters in it. And I think we are ready to look at the file. Perfect. All of our dependencies have been installed successfully. And as you can see, we have our .env.example file. And let's take a look. Now, the first three parameters are for the Twitter account. When you create your Twitter account, you're going to receive a bearer token, and you can paste it right there. And then since calling the filtered stream API on Twitter just sends you so much information, we need a way to filter it. So this parameter will define a query. As you can see, in this example, we're filtering by all tweets that mention Red Bull Racing and are in English. And when you do this on your own, you can play with this. You can put your own brand name there, your ad mentions. And if you look at the API reference, you can see it has a small language to define these queries, and you can play with it to fit your needs. Now, for the random tweet generator, I have it specified here, each of the parameters. It accepts number from 0 to 4. So if you give it a 0, it will generate negative tweets, 1 trending negative, 2 balanced tweets, 3 trending positive, and 4 positive. So you can play, and I'll show you this in just a little bit, just to gauge the sentiment. Next, we have our tweets per second. Again, for the tweet generator, you can control how fast this goes. For the image query, that again relates to the API to pull images from tweets, and it's another filter. Here we can see the processor server, again, port 9000 that we've been talking about the whole time, the listen address. This is our config file that contains the authentication information. And those are references to certificate files, which we are going to create in just a little bit. All right, so this is our configuration file. I'm not going to make any changes to it right now, and I'm going to rename it from .env.example to just .env, so our system will be able to pick it up and use the parameters in there. Now we're going to create a self-signed TLS certificate, so we can use HTTPS connection. Now this is a self-signed certificate. That means that our browser is not going to like it, but we're going to convince it to like it in just a little bit. Obviously, real certificates are, you can buy them from the various vendors, and this is not one of them. This is just as an example, and obviously not a production certificate or not a production way to do things. This is just an example. Now, the second step, we will have to supply the host name. Now, in our case, the host name would be the IP address. I'm going to move on, and just a few other steps here. Everything, all the steps are explained in detail right here if something is unclear. All right, lastly, we're going to remove the request file, and let's see if we have all the files that we need. We are looking for cert.pem and key.pem. Perfect. So those are going to be the certificate needed to set up in TLS connection, and our web server is going to be looking for those. All right, next we're going to test our configuration. Now this step creates the filtered stream on the Twitter API, so we are going to be skipping this, but all the details are here. Next, we want to make sure that the authentication we set up is working. So we do this with this little program called test OCI, and I'm going to show this program to you in just a little bit. So let's see if everything is working as expected. Yes, so everything worked out correctly. It issued a language AI API and returned successfully, and did the same for the vision API, and it also returned a success. So you can also use the --print just to see the results from the various API requests right here. As you can see, the first request was a sentiment analysis on some text, and you can see that the aspect day was spoken about in a positive manner. Our API returns confidence score for each of the various ways the sentiment can swing. As you can see, this is overwhelmingly positive. I'm going to show you the specific text. And then Oracle Cloud World, again, spoken about in a positive manner. This is the vision AI request. As you can see, it detected darkness because this sample image I'm sending is just one dark pixel. So it detected darkness. But this is just a test image, and I'm going to show you an example with real images in just a little bit. So let's oh yeah, if you like Python, if Python is your language of choice, we also have the same program in Python. Again, a tiny program to test the API, and I will show you this program right now. So let's open our favorite text editor, and let's go to our downloads and open our code bundle. So if we look here, this is the test OCI program. It's a TypeScript program. It is extremely simple, and I'm going to describe what's going on here. So first, we import the relevant packages from the OCI SDK. The SDK is available in all of the major languages. We're using common, AI language, and AI vision in this case. When we start, we need to describe to the SDK how we're going about our authentication. So in this case, we're using the config file that we created earlier with the tenant ID and the user ID and all that. And we're creating an object. We're not giving it any parameters. So the default is that .oci folder and a config file with all the information. Once we create that object, we create an AI service language client. This is the language AI client. We give it the authentication object that we've just created. Everything is pretty seamless. And from that moment on, if we have our authentication configured correctly, we are basically done. We can start using our APIs. Those are asynchronous APIs, of course. And in this case, we are calling sentiment analysis. Now, as you can see, all we provide this API is some text, and we get insights. And if you remember, we saw these insights right here. We're getting back a JSON payload and saying the word day was positive, and then Oracle Cloud World was mentioned positively. And it's not a surprise, it's a pretty positive sentence right here. And now we do the same for the vision call. As you can see, we don't have to redeclare our authentication. We have it already. So we just create a AI service vision client object. We're saying, hey, do image classification on this inline image I'm sending you. This is a base 64 encoded image. It's pretty much the smallest image I could find. And I'm submitting it inline. You can also supply reference to images that are saved on a storage bucket. If you have a large volume and you don't want to send them in the payload of the request. And then we're calling the analyze image API, and we get the response that we saw earlier. Obviously, this is just one dark pixel, so this is just an image of darkness. And let's take a peek at the Python example. As you can see, again, we're importing the OCI SDK for Python. We're creating, again, an object with the authentication information from the file. And as we did with the TypeScript example, we are creating an AI services language client. And from that moment on, we're just giving it some text. Again, doing the same with the AI Vision API, calling the API and classifying the image. Very simple, very straightforward. And if there's one thing that you take away from today is how easy and simple it is to call our AI services. And this knowledge is transferable to all of our AI services. The pattern is very similar. Maybe anomaly detection and forecasting will require a little bit more setup because they work on time series data. But for the most part, this is the pattern. These APIs are very performant, very simple to use, and I highly encourage you to test them in your own scenarios. Alrighty, so this is a little bit of a description here in the lab as well. And now it is time for us to actually see this code in motion. So we have a bunch of programs within this code. The consumer program uses the Twitter API, so we're going to skip it, and we're going to use the random tweet generator, which is described in just a little bit. And after we start the random tweet generator, we're going to run our processor. Our processor is our web server, and that web server does a few things. It collects all the information from the consumer program or the random tweet generator, which are just saved as files, and runs them through, reads them, and send them to the language or vision APIs to get processed in batches, and then sends the responses back to the client. So right here, again, a description of the various variables that the random tweet generator can consume. And I'm going to start the random tweet generator right here. I need my remote terminal. There we go. Okay. So I'm going to run the random generator in order to make sure that it is running. All of these processes are logging into text files. And as you can see, it's enqueuing tweets. Perfect. And now we are going to run our processor right here. And again, we can check its operation right here. All right. It's the queuing, running the API request. As you can see, it is batching groups of 100 tweets at a time and sending it. Now, let's start with our client. As I mentioned, our client is just static code on our computer. So we're going to have to force our browser to like it. But first, we need to do a couple of modifications to the code to include the IP of the compute instance. So let's look right here. As you can see, the default is localhost, and I'm going to need the IP. So I have it still open here. I'm going to paste it. One tiny thing I'm going to do here, since the service started returning some different responses lately. So we have a small code, but I'm going to make sure to update it. Is there a question?
Yanir, could
Yeah.
you potentially zoom in your screen just a little bit? I don't know if it's possible in the view that you're in.
Okay. Is this better?
Yeah.
Okay. Apologies. Thank you. Awesome. All right. So I have replaced the localhost statement here with the IP of my current instance. And let's load this up in our browser. I'm going to just open this file from here, source, and then centimeter demo, client, and I'm going to open the HTML file. Now, and this is the quirkiness I've been talking about. We need to open the files, the script files, in order for the computer to accept them. So I'm going to open the WebSocket client and refresh the page. All right. Let's see. So we are not. Oh, one other thing I didn't do is, since we are using a self-signed certificate, then our computer is not going to like this SSL certificate, as you can see. So I have a detailed explanation here on how to get over that, and it depends on your browser. In my case, I'm using a Chromium-based device, so I'm going to click Advanced, and now I'm typing, this is unsafe. This is unsafe, and let's refresh it. Okay, I think we're good. Now, each browser is different. And again, this is not a production scenario. This is just to make things simple. And here we go. We are now connected. As you can see, tweets have started flowing in, and we can see on our Centimeter that tweets are positive. We can see on our server that our processor is consuming the tweets generated by the random tweets generator, and everything is just super positive. So let's play with this a little bit. I'm going to stop all of my node processes, and I'm going to edit our configuration file right here, and I'm going to change this to be, let's say, pretty negative. And I'm going to start my processes again. Okay, the random tweet generator, and then we're going to run our processor, and let's try reconnecting and see what's going on. And we're connected, and data is, yep, as you can see, a bunch of mixed, but we're trending negative. All right. And of course, once you run the consumer and set up your Twitter API, then everything is going to be driven directly from data retrieved from Twitter in real time. All righty, so let's move on. The next step will be to show our vision demo. Now again, the lab comes complete with code that pulls images directly from Twitter. I'm going to stop my servers real quick. But again, those images might be a little unsavory. So we've prepackaged some images in this lab for you to kind of try this feature. So I am going to run the image processor. I'm not going to run the image consumer right now because I haven't set up my Twitter configuration. All right. And let's see if everything is starting. Yep. Okay, so it is processing images. Perfect. And I am going to start working on our Vision client. So as we did here with the language client, I am going to open our image analysis demo, go into client, open the HTML. And here we need to open lang and HTML. So let's open these files. Here, HTML, that's one, and then language, that's two. All right. Let's refresh. Okay. All right. And as we did with the language client, we need to update the IP address for our service. Let's see, where are we? Client, and then scripts. We're looking for this file. So again, replacing localhost with the IP so we'll know where to connect. Let's see, refreshing, we are connected, and let's see if images will start flowing in just a little bit. There we go. So here on the left, we can see all of the objects, object counts accumulated across all of the images. As you can see, obviously, those are images of cars, race cars and race drivers. So we have a lot of wheels in cars, in a traffic light. And these are all the text impressions that we were able to pick up. So let's see, if we click on one of the images, you can see that these are the objects we've detected: a car, wheel, tires. Here's the text that we were able to retrieve. Let's see another one. The images repeat. We only have, I think, 6 or 7 images. Helmet and person. As you can see, there's even a blurry person here in the background. And there's a bunch of text here all over the place. And as you can see, the orientation almost doesn't matter. It does a decent job retrieving all of the text from everywhere. And we keep all of the totals up here. And that, my friends, I believe, is the end of the lab. Yes, that is our last demo. Let me stop our server, and I highly encourage you to do the same, because it's actually hammering the APIs pretty hard. So it's important that you don't keep this running all the time if you don't need to, just to preserve your credits. And I believe this is it. I think we have ample time for questions.
Thanks again so much. We hope you have a great day, and we hope to see you again next time.
Thanks so much, everybody. Come talk to us on the Slack channel. Thank you.